Let's look a little closer at the idea of Venn diagrams. Darn, we just lost the picture again. Let's see if we can make it come back. Now, Venn diagram for two sets. I'm going to draw this a little bigger than we did in the last set. The sets are A and B. And we'll generally draw the Venn diagram like this, showing that the two sets might have an overlap. The overlap might be empty, in which case we might even draw the two sets to where they don't intersect, if that happens to be our information. Now, this diagram divides the universal set, and of course implicitly this outside set is the universal set, into how many regions. Count the regions that we have. Okay, there's 1, 2, 3, 4 regions formed by two sets. Okay, there's the region that we could denote by A intersection B. That's the region where the two sets intersect. The region we could designate by B minus A, which is everything in B that's not also in A, so that's this region. There's A minus B, which is this region, and there's this region. Okay, now what is this region? See if you can think. What is that region? Okay, this region consists of everything that's outside of both sets A and B. If we lump the sets A and B together and get the whole big set where we make the union of A and B, that's A union B. What's outside of A union B? That's A union B complement. So those are the four regions we get from the Venn diagram for two sets. Now, I think your text numbers these regions 1, 2, 3, and 4, and you can look up that numbering, but I'm going to use the reference here. If you have three sets, you also get a general Venn diagram. Okay, the three sets might be depicted like so. Here's your set A, here's your set B, looking just like they did before, and here's your set C, and we're going to draw a C so that it overlaps every region that we get when we draw A and B. We overlap the A intersection B, we overlap the B minus A and the A minus B, and we also come out here into the complement of the A union B set. How could we name these sets? Okay, if this is A, and this is B, and this is C, then what's this set in the middle? Well, we're going to call that A intersection B intersection C. Okay, so that's in the middle. What about this region here? Well, that's what's in B, but not in A or C. That's going to be B, but take away A union C, because we take away from B what we get when we lump these two sets together. What about this region? Okay, now this region is part of A intersection B, but it's not going to include the part that's in C. So what that's going to be is that's going to be A intersection B minus C. What's this region out here? Well, this is the region that's outside of what we get when we lump all three sets together. That's going to be the complement. Okay, if we lump the three sets together, that's called A union B union C. And then we put the prime on it to indicate the complement. So that's the complement of A union B union C. You might think how you might name these other regions. How many regions are there? Well, actually we could think about this. We had 4 regions, remember, when we just had A and B. If we don't have C, we've divided the universe into 4 regions. 1, 2, 3, and 4. When we draw the set C, we cut each of those regions into 2. You see that this part of the set C cuts the region that was here into 2 regions. And it also cuts the region here, the A minus B region, into 2 regions. It takes a chunk out of the 4th region, the outside region here, and it takes a chunk out of this region. So it takes a chunk out of each of the 4 regions that were already there with A and B and gives us 8 regions. Okay, we double the number of regions because each region gets cut into 2 pieces.